Hello, and welcome to your Week 8 Lesson 1 video, where we are going to look at linking files. So we're going to look at inodes and what they mean, the difference between hard links and symbolic links or symlinks, and when to use them. And ignore this assignment for a bit. That should not be there. I'll make a note to edit that. Oops. I thought I had gotten all these in my edits. It's a holdover from ULI 101, so that doesn't apply to you. Everything is in here that we talk about in this video is going to map to Investigation 1 in Tutorial 8. So inode numbers, or index numbers, they're unique for each file. They're like fingerprints for files. It's an index data structure that provides information about the file, such as whether or not it's a directory or a regular file, its file permissions, all kinds of information. And you can view these by including the -I option with the ls command. You usually do this with ls-l. And you'll be able to see that every file in a or in your directory in your file system has its own unique inode number, and that's what this number is here. So you're not used to seeing that. Now there's two ways of linking files. There's hard links, which reference the same file in a file system, and what happens with this is it creates a file that shares the same inode number. So remember I just said that every file has a unique inode number? Well, that's true except for when hard links are in use. The advantage of hard links is that if you delete one file, even if it's the original, as long as you have one hard link, then the data is not lost. And any changes between the files are replicated between the two. So you make changes to one, it's replicated to the other, which is useful for backups. The big drawback is one, they take up extra space on the file system, so that's could be disadvantageous. Of course, now we've got huge directories and hard drives and stuff. Directories. So we have huge hard drives and lots of storage. So that's usually not as much of an issue as it was historically. But still, every time you make a new hard link, it takes up extra space. The really big drawback is you can't create a hard link to directories, and you cannot hard link files from other servers because the inode numbers might already be in use. So here's some examples that we're going to run through. Creating a file, creating some hard links. So to create a hard link, you use the ln command, which is link. And I'm going to run through those in my little demo here that I've got ready for you. So I'm SSH'd into Matrix. I have the demo directory open in my OSL640 directory. And I'm going to create some files, and we're going to do some stuff. Let me make sure these files don't already exist, because I have a bunch of stuff here from previous things in the semester. So let's create an empty file. I'm going to call it myfile.txt. And I'm going to create a couple different hard links to that file. So to do that, we use the ln command, which is short for link, myfile.txt. So kind of like the copy command, what do we want to link and where do we want it to go to, right? Our source and our destination. So our source is the file we just created, and the link that we want to create, I'm going to call it myfile1.hard.lnk. And I'm going to do that a couple more times. I'm going to create a second one. And I'm just going to get rid of that. That's from an earlier thing. I'm going to create a third one in that backups directory. So this is going to be, put clicking on the wrong window again. Using a relative to home path name, of course. There we go. Then if I do an ls-l on my file, I'm going to see I've got a bunch of them. Notice the text is a different color. If I do an ls-l on on backups, my file. And of course, that's not showing you the inode number, is it? So for that, we want to ls-li on both of those directories, and look at that. We have 4 files with the exact same inode number. If I show you this, I don't think I did normally. We see that that doesn't exist outside of these files that were hard linked, right? All of the other ones have unique inode numbers. So that's kind of interesting. So that's one type of linking. The other type, of course, is what's known as a symbolic link, or alternatively a soft link or a symlink. And these are pointers to a file. The symlink contains basically the path name to the original file, and that's it. So advantages to these, they act as shortcuts to files, exactly like shortcuts you use in Windows when you create a shortcut to a file. And in fact, the symlink itself, the symlinked file, only contains the path name to the original file. Also, unlike hard links, you can create symlinks to different servers, and you can even create symlinks for directories. And this is how I've seen them commonly used in different service configurations. Sometimes they want you to symlink something, so that way if the package updates the original directory, it's reflected over. The downside to this is, if the original file is deleted, it's all gone. There's no redundancy. It's not a good backup solution. And then you're going to get broken links in your file system, which we're going to actually look at. So here's an example of how to create some symlinks. And let's actually see that in action, shall we? So back over to Matrix. I'm still in my my demo directory here. I'm going to create other file.txt, and I'm going to create some symbolic links or symlinks. So we use the ln command again, but we use the -s option. And you don't have to have this the hard.lnk or sim.lnk extension. I'm just doing that to make it easy to understand what's going on. So as promised, we're going to do 1, just like we did before. 2 in our current directory and 1 in the other directory. And if I do an ls-li on other file star, see, instead of whereas before it was in this hard blue with different same inode numbers, it's in this soft blue, this lighter blue, more of a teal color, and it points to the original file, even in the other directory. If I do this on my backups directory, whoops. Yeah, there we go. You can't see it because of the stupid activate Windows thing, but it's there. So let's see what happens when I remove other file.txt, and then I do an ln-li. Whoops, too far. or not far enough. They're red now. They weren't red before. So this is a broken link. If I do an ls-l, on a Linux system they'd be flashing. They don't flash in Windows, it seems, but it would be like flashing red, indicating that there's a problem. Oops. So there's an example of those. I'm just going to clean up my stuff. And that should more or less bring us to the end of, yeah, here we go. So to get more practice with these, work on your investigation 1 and your first 2 practice questions in your week 8 tutorial. And as usual, I will now see you in another video for part 2. So, thank you for watching, take care, be safe, and I'll see you there momentarily or a little bit later.